Problem number 14 on the final review says a shipping company is designing boxes to meet specific requirements. Each box must be a completely closed rectangular prism with no overlapping material. The boxes must hold 24 cans in 2 layers of 12 cans each, and the cans are 13 inches in diameter and 5 inches in height. What's the smallest amount of cardboard needed to meet the specifications? So just a couple things. First off, when we're talking about cardboard to enclose these boxes, we're talking about surface area, right? And surface area is basically just means find the area of each side of the box and then add it all together. And this is a rectangular prism. So there's gonna be rectangles, rectangular prism. It's just going to be a rectangle on every side, right? So formula-wise, all we really need to understand is to find the area of one side, you just do the length times the width, right? But we're going to have to do that for every side. So now the smallest amount of cardboard. So let's just actually kind of try to design a couple boxes that fit these requirements, okay? So we've got... It has to be a rectangular prism, no overlapping material. They have to hold 24 cans in 2 layers of 12 cans each. So I'm going to imagine 12 cans stacked on the bottom and then 12 cans stacked on top of them. And the big thing is 12 cans each. How do we arrange those 12 cans? I mean, we could arrange them like here's a can and then... So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 12 on top of each other, just in a single layer, a very long, skinny box of cans, right? And this would be 12 cans in 2 layers, 24 cans in 2 layers of 12 each, right? But we could also imagine the cans, so this is like a side view of a really long, skinny box. Let's do a top view of, maybe we could also arrange the cans. Here's 12 cans, right? Top view, a top view. So here's arrangement 1, right? Side view. Here's arrangement 2, where we could do 1, 2, 3, 4, 5, 6. We could arrange them in a 2 by 6 can arrangement and then stack them. So then this would be stacked on top. We would get another stack of that, right? We could arrange them in 4 rows of 3, right? So this would be a 3 by 4 can arrangement and then stack cans on top, right? So there's a couple of arrangements that are possible. This is the top view for number 3, right? So this is we could do like a 1 by 12 arrangement, a 2 by 6, or 3 by 4. And then the cans are 3 inches in diameter and 5 inches in height. So we're going to need to find out what kind of surface area would enclose each kind of these arrangements and see which one is the smallest amount, right? So let's start with arrangement 1, where we're just doing the long, skinny arrangement, okay? So the long, skinny arrangement is going to have in 1 row, right? So it's going to have 12 cans. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? And remember they said the cans are 3 inches in diameter. So, you know, this is the side view. If you took the top view, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Each one of these is 3 across, 3 inches across, right? So if this is 3 inches across, then that's 3, that's 3. So really we have this, how long this is 3 times 12, which is 36. And how wide it is just 3, right? 3 inches by 36 inches. But then when we're talking about how tall it is, so this is like top view, right? And this is a side view right here. Side view, this is going to be, they said this is, each one of these cans is 5 inches tall, so that's going to be 10 inches here, right? So this is the side, this is the top, right? So what we're going to imagine here is a box that, in this box, it's going to be 10 inches tall this way. It's going to be 36 inches long this way, but it's only going to be 3 inches wide. It's going to be a very long, skinny box, right? And we need to find the area for each of these sides. And remember, there's 6 sides. There's going to be 2 sides that are this 10 by 36, one side here, and then the same on the other, right? So 10 by 36, so the area of this rectangle, the 10 by 36 is 360, and there's 2 sides of this, right, that are 360 square inches. Then there's this side right here that's going to be 3 by 10. So we've got the 3 by 10 side, that's 30, and remember that's 2 sides, this side and then the one over here. And then we've got this, let's see, we haven't looked at the top side. This top side is 36 long, but just 3 wide. So we've got 3 times 36, which is, I think we'll just go ahead and do that. 3 times 36, 108. So that's 2 sides. So now, if there's 2 of these, right, let's see if we can zoom in right there so you can see what I'm doing with the calculator. So basically we've got two sides that are 360, so that's 2 times 360, and we've got 2 sides that are 30, so that's 2 times 30, and we've got 2 sides that are 108, so that's 2 times 108. And so altogether, this would be 996 square inches of material to make a kind of box that had 2 long rows of 12. So if you look, that's actually not even one of the answer choices. So we can say for sure that it's not the smallest amount of cardboard. But we can also say for sure then we can cross out A, because we know we can make a box with 996 square inches. So clearly this, so just by calculating this, we're able to eliminate one answer choice. This is obviously not the smallest amount of cardboard needed, because I can make a box with less. Okay, so now we know it's going to be one of these answers, right? So we already have increased our chances. So now we need to kind of imagine that 2 by 6 box, right? So remember the 2 by 6 box. This is the top view, right? So that's going to require a 2 by 6 box. Remember, each of these are 3 across. So if this is 3 and that's 3 and that's 3, they're all 3. It's 3 times 6, 18 inches across. And then this is 3 and this 3, so that's 6 inches wide. And again, we still have a box, right, that requires us to stack 2 cans, right? So if these are stacks of 2 cans, then we know it's going to be 10 inches tall, right? So we've got 18 inches wide, or long, 6 inches wide, and 10 inches tall again. So each of these boxes is going to end up being 10 inches tall with them stacked. So again, we just need to calculate the area of each side, right? So we've got this side, right? This top side is going to be 18 times 6. Let's see if we can zoom in a little bit there. Okay, so we know that one side is going to be 108 square inches, and there's going to be 2 of those sides, right? And then we've got one side right here that's going to be 10 inches tall but 6 inches wide. So that's 60 square inches, and that's 2 sides, right? And then we've got this front panel that's going to be 10 inches tall but 18 inches wide. So that's 180 square inches, and that's 2 sides, right? So again, we need to do 108 times 2 plus 60 times 2, times, plus 180 times 2 to figure out how much total area it's going to cover. So that gets down to 696 square inches, right? So again, looking here, that's not one of the answer choices, but already again, we can now eliminate B. We know B is not the correct answer. We know that it has to be one of these two. So now we have a 50-50 chance if we had to stop and just guess, but we don't have to. We're going to go ahead and imagine that 3x4, right? 3x4 situation. So a 3x4 box, right, is going to be 9 inches long, because remember 3, 3, 3, and then 1, 2, 3, 4, 12 inches wide, and again 10 inches tall, like all of these boxes, right? So I'm going to go through this pretty quickly because it's the same process. This side's going to be 12 by 9, 12 times 9, so we've got two sides that are 108. Then we've got 12, this front panel 12 by 10, so that's 120. And this side panel that's 9 by 10, so that's 90. So we'll do this twice. 120 times 2 plus 108 times 2 plus 90 times 2. And that gives us 636, right? We did each of these times 2 and then add, right? So 636 square inches, and that is a choice here. And I can't think of a different way to arrange 12 cans in this way. So I'm going to go ahead and say that this is definitely the smallest because I can't think of any other way to do it. And in fact, it is.